All right, we're moving on to chapter 5 in our textbook, which is all about chemical reactions. So what I'm going to do is give one of my favorite chemical reactions, and this is a reaction between hydrogen, which is H2 in its elemental form, and oxygen, which is also O2 in its elemental form. If you combine both of these together, along with an ignition source, you'll just make water. So you might be thinking, well, why are you fascinated by this reaction? Well, number one, it's really loud. In fact, once I did this as a demo and almost blew out the glass windows in my room. And number two, this is the reaction that was used to launch the space shuttle. So if you think about that big orange tank on the space shuttle, it was actually full of liquid hydrogen and liquid oxygen, and it released a huge amount of energy through the form of water vapor, which is what was used to lift the space shuttle into space. All right, but there's a few things we need to think of when we think of this reaction. Number one is we want to include the state of whatever particle we're talking about. So in this case, H2, we're just going to call it a gas, right? So over here, we'll just say G equals gas. All right, and then oxygen, kind of same thing. We'll say that it's a gas. We like to indicate the state of our reagents. Over here, when we make water, we'll just assume that it's going to be a liquid. So L equals liquid. Some other ones that you might occasionally see are pretty simple. S equals solid. And AQ equals aqueous. And you might be wondering, what the heck does aqueous mean? Well, if you think about the root here, aqu means water, so it means something dissolved in water. So let's just write this down. All right, so we want to always include these states just to be really thorough to our reader to indicate what we're doing during this chemical reaction. So this is specifically stating to the reader that we're combining hydrogen gas with oxygen gas to create water, which is going to be created in its liquid state. All right, but there's some other things we need to kind of talk about, some general terminology. Over here, this whole region, let me make this bigger. This whole region, these are called the reactants. Oftentimes, you'll hear these referred to as reagents. They're basically the things that you put into the reaction. Where over here, on this side, we're going to be looking at our products. So I know that seems pretty intuitive, but I just wanted to make sure we got the correct terminology as we go through this chapter. All right, there's one other thing that we've talked about a little bit, but let's kind of redefine this, and I'm just going to write it out for you. This is the law of conservation of matter. And the law of conservation of matter makes a lot of sense. And it says that atoms can not be created or destroyed in a chemical reaction. This is true for the vast majority of cases. You'll often hear this referred to as the law of conservation of mass. There are some kind of oddball examples involving nuclear chemistry. So if you're talking about a nuclear bomb going off, for example, you're actually changing an atom into something new and actually losing a little bit of mass. But we're not really going to talk about making atom bombs in this class, so we're going to just assume that this holds true. All right, but let's go ahead and look at this reaction that we've done up here. So if I go over and I look at my hydrogen atoms, I've got 2 hydrogen atoms on this side, meaning our reactant side, and I've got 2 hydrogen atoms on my product side. So that's good. We didn't create any, we didn't lose any. Let's go to oxygen though. So over here, I've got 2 oxygen atoms, but over here, I only have 1. So now the question is, how in the heck do we fix this? We can't lose an oxygen atom out of nowhere. Well, what we need to do is we need to actually put in what are called coefficients. And the way I like to describe coefficients is these are whole number multipliers. So for example, if I write 2 in front of water, that just means that I've got 2 water molecules. You don't need the parentheses though. As long as it's a big 2 in front, that indicates that we have 2 water molecules. So now if I look at my oxygens, I'd say, well, I've got 2 oxygens here. And then because this is a 2 as a multiplier, this means that I have 2 oxygens. So now I've got 2 oxygens on each side. That's good. If I go over and double check my hydrogens again though, I now have 2 hydrogens here, but over here I've got 2 times 2 equals 4 hydrogens in my water product side. So what do I need to do? Well, it's pretty straightforward. I just need to multiply this side by 2. So now we can go and do our final check, and I'd say, well, over here we now have 4 hydrogens. Over here we have 4 hydrogens. That's good. We haven't created or lost any hydrogens. And then over here I've got 2 oxygens, and over here I've got 2 oxygens due to this 2 multiplier. Okay, so let's make a little note here. So these are called reaction coefficients, or just coefficients. And these act as a whole number multiplier. You may see in some of your bio textbooks them using fractions. So for example, 1/2. However, I prefer that we stick with whole numbers, and most chemists do for that matter. So we're just going to stick with that rule that we want to keep whole numbers in here. All right. And it's important to remember that we want these whole numbers to be the least common or the smallest multiplier possible, right? So we wouldn't, for example, want to do anything like, hey, let's do 4 to 2 to 4. We could reduce that to 2 to 1 to 2. And we don't need to include a 1 right here. It's just implied if you don't have a number in front that you're only talking about one molecule. All right, let me show you a common mistake that students make. And this is something that you might run into as you go through practice problems. So I just wanted to clear it up. So let's say I tell a student, all right, we're going to combine hydrogen and oxygen to make water. Draw out the chemical reaction. Well, a lot of students would say, all right, I'm going to combine hydrogen and I'm going to mix that with oxygen and I'm going to make water, which is H2O. This is not correct. Why is it not correct? Well, first of all, it's not balanced. So a student might say, well, now is it correct? Still not, right? Because this is not a real reagent. You can't go to a store and just get hydrogen atoms. They're way, way, way too unstable. So the elemental form of hydrogen is always going to be H2. Same thing over here. This is not a real reagent. And again, this is because the elemental form of oxygen is O2. So this is not allowed. So I would go through and I would just say, let's cross this out. That's not a proper reaction. We need to make sure that when we do this, we're using real molecules. We're using real atoms that can exist, be purchased, be combined together with other things. We don't just select individual atoms if they're unstable on their own. All right, I hope that helps. In the next video, what we'll do is we'll take a look at the wide variety of chemical reactions that can take place, and we'll start jumping into redox reactions.